Okay, for this video, this is for learning target 3.3, relative dating, and basically explaining how we use the law of superposition and a few other laws to help us determine the age of different events, but not the exact age, just putting them in relative order with each other. So the big ideas for this learning target are understanding the law of superposition, the law of cross-cutting relationships, and being able to put events in order if you're given a cross-section of the Earth. Let's start with talking about the difference between relative dating and absolute dating. Relative aging or dating is putting things in order or sequence, but not actually really knowing the exact time. Sometimes we can estimate how old something is, but relative dating is really just limiting us to the order in which things happened. Absolute dating is being able to put an actual date to the time that something happened, and we can use that with radioactive decay. And in learning target 3.2, we learned about that. So the first major law of learning target 3 is the law of superposition, which basically says when we get sedimentary rock, they form in flat layers, and the layer on the bottom is the oldest, and the layer on the top is the youngest. So we can see in the upper left-hand corner of this diagram here, we've got 4 layers, and layer 1 would have been the first layer deposited, then 2, then 3, then 4. We didn't do our rocks unit this year. That's the first year we didn't have to learn about the rock cycle. Just to have a little background information, sedimentary rocks form when sediments sink to the bottom of a lake or ocean or body of water, and so as sediments slowly accumulate, we get layers. So as long as we have an ocean or body of water depositing sediments, we'll continuously get sedimentary rock. So we can combine the two learning targets, our last one and this one. When we have layers of rock, we know that the bottom one has to be the oldest and the top one has to be the youngest, and occasionally we can find radioactive elements, maybe from a lava flow or a volcanic eruption, and we could get an exact date of certain parts and then estimate the layers in between. The next principle or law that we learned about was the principle of original horizontality, which basically means that when sedimentary rocks form, they form flat. So if they're not flat, then something had to happen to them. And we usually refer to that as a fold. The next one we're going to talk about is called the cross-cutting relationship. And the cross-cutting relationship is when something crosses over something else, it has to be younger than the things it crosses over. So in this bottom right picture, we see we've got 3 layers, and then we have number 4, this diagonal line. This is probably like magma coming up to the surface. We call it an igneous intrusion. And number 4 crosses over 1, 2, and 3, but it doesn't cross over 5, which means that 4 had to be there before 5 was present. So we'll look at this one a little closer. The one above that one is an example of a fold. This is the law of original horizontality. This is how it normally forms on the left, which means if we see your rock layers like this on the right, that means there was some pressure that had to fold it after they were already made. And the last thing is something called an unconformity. And there's 3 types of unconformities. We didn't really dive into each of the 3 types, but all 3 types are showing a different version of the same thing, which is that there's a gap in the layers of rock. So this is an example of a disconformity, and again, you don't have to know the differences between these, but we can see that this layer and this layer doesn't match up. This kind of jagged black line represents a border between these layers of rock and these layers of rock. So there's a gap in time between this the top part of our bottom section and the bottom part of our top section met together. So if we look at a example, this is one that we did in class. So a general rule of thumb of being able to put these things in order is we use the law of superposition to tell us that layer C had to be here first, then B, and then A. And then we have D, which is an igneous intrusion, in E. And we use the cross-cutting relationship to tell us that D crosses over all three of those layers. And we can see that E actually breaks through D, so E had to come very last. So the correct order would be C, B, A, D, E. So on our quiz on Tuesday, I'll give you some, maybe like one simple one, like this one. So we can see that the bottommost layer would be E, T, and then O. And then we've got a fault line here, but this breaks through all three layers, so it had to be very last. And then I'll most likely give you a little bit harder one, maybe one like this or one like this, where we've got multiple layers and multiple faults. So let's do a harder one like this one. So again, we always start at the bottom, and we're going to work our way up. So we've got G, C, E, and F. And we can see that the fault line B breaks through all of those layers, so that one's got to be next. And after layer F, we've got H, D, and I, and then we know that the fault line E had to come very last because it breaks through everything. The only other thing I'd like to point out is this is an example showing the principle of original horizontality. We've got these four layers in the bottom, G, D, F, and E, that are not flat. They're curved. They're folded, which means that after E was formed, then there was some pressure that caused them to be squished and not flat. So the correct order for something like this would be G, D, F, E, then a fold. And then we can see we've got this dark squiggly line which represents a gap in time. So that's got to be an unconformity. Then it would be C, H, B, A, and then the very last thing would be a fault because the fault cuts through everything. So this would be an example of a harder one that you'd have to do. The only other thing that we haven't talked about is an igneous intrusion. So the dotted lines or hash marks around igneous intrusions represent basically burn marks or burning. Igneous intrusion represents magma. And magma is obviously really hot, and as it comes up from below, it burns the rock on its way by. So in this case, we see there's a dotted line above and below layer F, which means that this igneous intrusion burned layer A, also burned layer G, which means layer G had to be present in order for the igneous intrusion to burn it. So the correct order for this one would be D, C, I, H, then a fold, then a unconformity, B, A, G, F, E. Again, F had to come after G because G was burned by F. So those are examples of all of the laws. Good luck.